Netflix and Spotify are some of the leaders in personalized recommendations. And it is quite fascinating how they're able to predict what we are going to like. In this podcast, we will cover recommendation engines, which are quickly becoming one of the most popular topics in data science. What I love about them is the combination of psychology, computer science, and math that I feel is as much art as science. This podcast assumes no prior knowledge of this topic. To get the intuition of recommendation engines, we will talk about how we recommend movies to others in our day-to-day lives. We will take two examples. First, say you have a friend Adam and you don't know him very well, and he asks you for a movie recommendation. Most likely, you're going to ask him which movie he has liked in the past. So if Adam tells us that he loved Interstellar, we might recommend him the movies Martian or Contact, which are also movies about traveling in space among different worlds. This would be a content recommendation engine. We are just basing our recommendation on a movie your friend liked and finding other movies of the same genre. This is a safe choice, right? There is no way your friend is going to hate you if they did not like your recommendation. So that was the first approach, which is the content recommendation engine. The second approach is something you might do with closer friends. Friends you have known for quite a long time. Say you have a close friend Becky. There are certain movies that you know Becky will like. If you know she is edgy and loves thought-provoking movies, you might quickly recommend her Inception and Shutter Island. The way you recommend these movies is because other friends of yours who also love thought-provoking movies loved these two movies. So there are two main things that are kind of going on in the second approach. First is that you did not have to ask Becky for a movie that she liked. You're just able to go ahead and recommend something because you know her very well. That is, you know what kind of ratings she has given to different movies in the past. Second, even though Inception and Shutter Island are not exactly of the same genre, you're confident of your recommendations. In fact, you don't even care what their genres are technically. IMDb might be classifying one of them as drama and another as mystery or whatever. The reason you're so confident of your recommendations is because you know Becky very well. Because you know her very well, you're able to picturize what movies she's going to enjoy. There is more freshness with this approach. You're relying on what other users similar to Becky have liked in the past. This approach is called collaborative filtering. In particular, using what similar users have liked is called user-user collaborative filtering system. Collaborative filtering works really great for freshness of new content. It uses quality judgment of others and can recommend outside the type of content you have interacted with. So you might not have ever seen any anime movie in the past, but you might still be shown an anime movie because users similar to you have liked anime movies. So you're able to see new kinds of movies even though you have not interacted with similar content earlier. So in the first approach, we only relied on the genres of the movies that you have seen in the past. So you might not be shown new kinds of movies, only the ones that you have kind of seen in the past. So all this sounds really good, but as you might have guessed, there is one problem with collaborative filtering systems. What if there is a new user and we don't know if they like thought-provoking or romantic movies? That case would be similar to our first friend Adam, whom we did not know much about. Also, if there is a new product and there is not a lot of information about user engagement on it. So if it's a new movie that has come out, none of our friends has seen it, how would we know if our friend Becky would love it or not? These problems are called cold start problems. To overcome these problems, you can combine both approaches of content recommendation and collaborative filtering. For new users, you can ask them 2 or 3 movies that they have liked in the past. So it's similar to what we asked from Adam when he told us that he liked Interstellar. This will allow us to recommend movies similar to these while we evaluate which content they like and love the most. Also, we can just recommend the most popular content on our site, or we can use that person's age and demographics to recommend movies. As we get to know the new users more and more, we can progressively start using more of collaborative filtering methods, which we have talked about. So to summarize, we use content recommendation system to recommend products based on their similarity, based on their content itself, their tags, their genres, and other kinds of things. Collaborative filtering uses user activity and user ratings. Collaborative filtering relies on both implicit and explicit data. Implicit data means just the act of browsing, listening to a song, watching a movie, finishing a movie, and so on. And explicit data is when users give actual ratings to products from 1 to 5 stars or thumbs up or thumbs down. So that brings us nicely to the next topic, which is how do Spotify and Netflix actually work? Spotify relies heavily on collaborative filtering algorithms. What Spotify does in the case of new songs is quite fascinating. So if you remember, new products are always hard to recommend because you don't have any user activity on them. And this is the cold start problem. So what they do is they actually convert the audio signals of songs into spectrograms. So spectrograms are visual representation of frequencies of songs. So it's something like heat map. And they run convolutional neural networks to classify these songs into different labels, such as hip hop or country or rock or heavy metal and so on. Then they create new playlists called Release Radar to encourage more user engagement, and slowly their collaborative filtering algorithms can kick over. I actually think that's a very fascinating and interesting way to encourage user activity on new songs. Also, they ingest a lot of unstructured text from blogs and reviews and try to find similar songs and bands from there. So if a blog is talking about Metallica, Megadeth, and Iron Maiden together, Spotify can start to understand that these three bands might be representing similar genre. This way, their content recommendation engines are heavily used in the beginning of a new song's journey, and slowly, collaborative filtering algorithms can be used in addition. I'm sure this is a huge simplification of their complex algorithms, but this high-level overview is also quite fascinating. As for Netflix, Netflix uses both implicit and explicit data of user ratings as well as streams. So, Netflix uses a hybrid recommendation technique that combines both content and collaborative filtering systems. From what I've heard from their talks on YouTube, they also do a lot of work on not only which movies to recommend in each row, but also how the rows on your homepage are arranged. So, drama followed by Because You Watched, followed by Netflix originals, etc. is actually curated for you. It is not fixed for everyone. This is really fascinating. Next, we will talk about the actual implementation details of building a recommendation engine. So to get started with recommendation engines, if you want to start playing with them and get to understand all these concepts, we can use movielens dataset that has actually a collection of 100,000 ratings, which have been applied to over 9,000 movies by 600 users. So 600 actual users have rated about 9,000 movies, and this is that data set. So it's actually really nice to get started with a lot of these concepts.